Hello, friends. Okay, in this session, I will explain about normal distribution. Normal distribution that is very important in business statistics, and that's why uh, here in this session I will cover about normal distribution. Okay, so let's start. So as you can see on your screen, the first topic there it is written continuous probability distribution. So what this continuous probability distribution is, so it is nothing but mathematical expression that defines the distribution of, now you can see here, I'm reading here from here, now you see. Okay, I think it is not okay. Now I will have to select that, then after I will be able to draw something. So hold on, now here I am. Okay, so here I was talking. Now this one, it is mathematical expression that defines the distribution of values for a continuous random variable. It means that for any kind of random variable, okay, and particularly here written continuous random variable, for any continuous random variable, this is the distribution of values, means how values are distributed. Okay, so how values are distributed, this can be represented by using mathematical expression. Okay, and that mathematical expression is nothing but continuous probability distribution. It means how values are distributed. Okay, that is continuous. So three continuous probability okay, wait, so here you can see written three continuous probability density function. Okay, so here written continuous probability density function. So here that it represents what is the probability of the distribution of values, or you can say how values are distributed and what is the probability of any value in the distribution, so that can be represented using continuous probability density function. Okay, a function, as you already know, that it tells the relation in between two variables. Okay, so here if it is probability density function, it means by using this probability density function, you will be able to understand that what is the probability of getting a particular value in the distribution. Okay, for instance, if numbers are distributed just like 1 2 3 4 5 6, okay, these are the numbers if distributed, so what is the probability of getting 3, okay, in the distribution. So now this is the distribution. Okay, the first 1 2 3 4 5 6. So how these numbers are distributed, okay, and how out of these numbers we can get any particular number just like 3. So what is the probability of getting 3 in this distribution? So that relation is represented by probability density function. Okay, now so three kinds of continuous probability density function. So the first function, that is normal distribution. What is that? Normal distribution, and the name of this chapter is also normal distribution. So we will go into depth on this normal distribution. So first see what that means. So written here, symmetrical and bell shaped. So normal distribution, it is symmetrical and bell shaped. means that most values tend to cluster around the mean. So around mean value, most of the values are clustered. Okay. For instance, now you can say this is bell shaped, so this is normal distribution. Here this one, shape of this one, it is bell shaped. Okay, this is bell shaped, and this one, it you can around this one, it is in the center, that is the mean. So now you can see around this mean most of the values are distributed. So now you can see here, so whatever I am here, I'm representing, so this portion, around this portion here, you have most of the values. Okay, so that's why here given, so most values tend to cluster around the mean. So that is the property of normal distribution. Then the second kind of distribution given, uniform distribution. So what happens in uniform distribution? So here each value has equal probability. Okay, so each value has equal probability means you can see whether the number is here or here or here. So at each point, or you can see at each value has equal probability of occurrence. Okay, so if five numbers are there, just like 1 2 3 4 and 5, so out of these all five numbers, the probability of getting 1 is the same as the probability of getting 4. So that's why here given each value has equal probability of occurrence anywhere in the range between the smallest value a and the largest value b. So here if you assume this one, it is smallest value a, and this one, it is largest value b, so this is the range from a to b. So each value has equal probability. So whether it is 3 or whether it is 4, for all these numbers, there it is equal probability. So that's about uniform distribution. But in case of, now you see just above there it was normal distribution. In case of normal distribution, the probability of occurrence of any value or any number is maximum around mean. Okay, maximum around mean. The, we can say, probability of getting any particular value is maximum around mean, and probability of getting any value uh, is uniform in the whole range in case of uniform distribution. So that's the difference, you can say, in between a normal distribution and uniform distribution. Then you have exponential distribution. So what happens in exponential distribution? In case of exponential distribution, this distribution is skewed to the right. So skewed to the right means, now you can say this one, it is the right side. Okay, so this is right side. So here in this case, this distribution is skewed. It means most values will tend to be towards the lower side. Okay, so that's again making the mean larger than the median, and range here 0 to positive. So the range of values will be from 0. So from here 0 to positive. So positive means any value it can be, it depends on the range of the distribution. So it starts from 0 and ends at whatever kind, whatever the value there it is in the distribution. Okay. Now next you have normal distribution. Yes, so this was the name of the chapter. So now that topic came here, normal distribution. So what happens in normal distribution? So this normal distribution is also known as Gaussian distribution. Okay, so let's talk about this normal distribution. Most common continuous distribution used in statistics. Okay, normal distribution is the most common continuous distribution. Okay, so normal distribution is the continuous distribution which is most, or you can say, you can most common use in statistics. So in statistics mostly we use normal distribution. So why we use? So now let's see in the importance of why we use. So the answer of that you will get in importance of normal distribution. So first, numerous continuous. Now you see, first here I'm talking numerous continuous variables common in business have distribution that closely resemble the normal distribution. It means no numerous means so many kinds of continuous variables common in business. Okay, so variables which are common in business have distributions that closely resemble the normal distribution. So that is very important. So that's why we uh, study normal distribution, and we use mostly in statistics. So the first reason, so in business many kinds of continuous variables have distributions so that closely resemble the normal distribution. It means mostly whatever we see the distribution in businesses, so those distributions are closely you can say closely resemble the normal distribution. The second one, given normal distribution can be very approximate various discrete probability distribution. Okay, it is also approximate various I think here it was something okay, it used to approximate. So normal distribution can be used to approximate discrete probability distribution. Okay, so discrete probability distribution can be approximated using normal distribution. So we will study these things in detail later on. So here only the intro part, so that's what we are talking. So third, given normal distribution provides the basis for classical statistical inference because of its relationship to the central limit theorem. So there it is a relationship in between classical statistical inference. Okay, basis. Now here normal distribution provides the basis for classical statistical inference. So whatever inferential statistics we study now, so that is based on normal distribution, and that is also related to central limit theorem. Fourth one, given in the normal distribution you can calculate the probability that various values occur within certain range or intervals. Here by using normal distribution you can calculate the probability. It means if any uh, distribution it is normally distributed, then in that case we can approximate what is the probability of occurring of, or you can say occurrence of any particular value. So that kind of thing we can approximate. That means probability can be approximated. We can calculate the probability of different values that occur within certain range or intervals. Then you have properties of normal distribution. So normal distribution, now importance you got. Now now we have properties of normal distribution. It is symmetrical, means mean equals medium, sorry, median, not medium. Okay, it is symmetrical, that whenever the distribution is symmetrical, then in that case mean equals median. Now first it was, second it is bell shaped in appearance, and its interquartile range is equal to 1.33 standard deviation. So we will get to know about this, what this interquartile range. It is infinite, it is infinite range, that is minus infinity to plus infinity, and the range can be. So Now I will show you this one here. This is what normal distribution here. Okay, so the range here, it is from this left side, from minus infinity to this plus infinity. Okay, so now you can see on your screen that normal distribution is bell shaped. So here three distributions are represented. So the first distribution, it is A, second distribution, it is B, and third distribution, it is C. Okay, so we will get to know those things in detail. Next you have normal probability density function. So density function, so probability density function is nothing but the kind of relation here. So it tells about how means how the probability of distribution can be found. Okay, by using this function, means by using normal probability density function, we can find the probability of occurrence of any value in the distribution. So here fx, that is the function of ax, means so if we need to find the probability density, okay, if we have to find out the probability density, then we can use this, and that equals here 1 by square root of 2 pi okay, sorry, here you have this function. So here this e, that is a mathematical constant, pi, that is mathematical constant again, the values are already given here. So for e you have this value, for pi you have this value, then this mu, you have the mean. Okay, so this is the mean of the distribution, and here sigma, that is the standard deviation. And about mean, standard deviation, about this all you have already studied. And if you have not studied about this, then you can watch my remaining videos on mean and standard deviation, so you will get to know about this all in detail. So x is any value of continuous variable from minus infinity to plus infinity. You have as any range, sorry, any value of continuous variable. So x is the value. Okay, what is this? X is the value in the continuous variable. So now you can see in the above equation here, here out of these four, these two are constant. It means the value of or you can say the probability will depend only on mean and standard deviation. Okay, it means value, so x, where will be the value of x, so that depends on the value of mean and standard deviation. It means only mean and standard deviation affects the probability of random variable x. So now here written, since e and pi are constants, the probabilities of random variable x, okay, probability of random variable x are dependent only on the two parameters, that is mu and sigma. So here mu, it is mean, and this one is standard deviation. Okay, so standard deviation and mean are the only parameters which affect the probability of random variable. Okay, probability of random variable x. So here in this figure you see for a and b, so this one it is a, and this lower one, it is, sorry, this lower one it is a, and upper one it is b. Okay, so in this same mu, see mu means mean. So now you can see for A and B both, so you have at this point mean. Okay, and but different this standard deviation. Okay, so standard deviation it is different. So that's why, so or you can say spread of A and B are different. A is spread more as compared to B. Okay, so now you can see here B here only spread here this lower one, and A spread up to here the upper one. Okay, it means, or you can say the dotted one, that is A, that is more spread the spread of A is more and the spread of B is less. So it means here standard deviation of A is greater as compared to B. Okay, and here in case of C you see a standard deviation, mean and standard deviation both are different, because the mean for this one, or you can say here if I write down mean here, and the for C the mean is at, mean is at this place. Okay, so mean for C it is so mean for C and mean for A and B. Okay, so these two are different. So mean and standard deviation will decide so what it will be the spread, or you can say probability of random variable x. So random variable, whatever I'm saying, so it means the variable for which we have to find out the probability. Okay, because we are talking about the probability now. So here now you see written, since equation 6.1 is tedious, now the above equation here, this equation normal probability density function, so this equation is very tedious, and for solving this you need integral calculus. Okay, so that's why another method we use to find out the probability of any random variable. Okay, so for that what we do, some process. Okay, is process here given. So the first step here, convert any normal variable x to a standardized normal random variable z using transformation formula. So here given, convert any normal variable x to standardized normal random variable z. So what that means is that we need to convert whatever the value of x given to its equivalent of value, means in other value. For example, if x value it is given 50, okay, and I'm going to explain here, I'm talking about how we can understand the meaning of normal random variable z. So if x is 50, and if we assume that in case of random variable x here given 50, if we assume that in other situation that okay, it is like this in case of z. Okay, for z what we can do, it is z value we can get by dividing x by 10. Okay, then z value what do we get here, 50 divided by 10, it means 5. It means for x equals 50 we get z equals 5. Okay, so it means 10 is the factor by which that x and z differs. You can think of this one in simple language, that this is a kind of unit conversion like of thing. Okay, it is not exactly that, but that kind of thing, just like we say 1 meter 1 meter equals 100 centimeter. Okay, so here whether you say 1 meter or 100 centimeter, both are correct. Okay, So but we use these two units according to our ease of using these units. Means if it is a 5 meter or 10 meter, then it will be easier to use meter as the unit. But if it is some 10 meter or 5 meter, then it is not better to use, or it will not be convenient to use centimeter or millimeter, that kind of unit. Okay, so what we do, we can interconvert. So that kind of interconversion is there. So for example, if you have to convert from centimeter to meter, then what you do, you divide by 100, then you get in meter. Okay, in the same way here, for converting x to z, some factors are there. So or factors are there, or you can say some parameters we use to convert, and those parameters here in this case given it is mean value and standard deviation. By using these two, we can convert the x value into z value. Okay, this is only the normalized value. Then you have second one. So now z value you got. Then next what you do, determine desired probability using the cumulative standard normal distribution. So now here given using cumulative standardized normal distribution. So probability, how we can find probability of x. Okay, we are talking about probability of x, or you can say probability of random variable x, we can get by using cumulative standard normal distribution. Okay, cumulative. So by this it will be much clear. So now you see this one is the normal distribution. Okay, in this is normal distribution, and here you have this one, this is mean. Okay, this is mean, and around this mean you can see to the right side written mu plus 1s, mu plus 2s, mu plus 3s. As here it is standard deviation, mu plus 1 standard deviation, mean plus 2 standard deviation, mu plus thrice standard deviation. Okay, then in the same way here, if we go to the left, then it is mean minus 1 standard deviation, mean minus twice standard deviation, mean minus thrice standard deviation. Okay, so here you see here the distribution written, means distribution of x. Distribution of x, it is 1 3 5 7 9 11 13. This is the distribution of variable x, random variable x. Okay, this is the distribution of random variable x, and for this random variable x, the mean here, m here, now you can see to the right side, x scale written, x scale. In this x scale, mean you got 7. Okay, and in case of standardized value of z, now here you see there it was written, convert the any normal variable x to a standardized normal random variable. So converting from x to normal random variable z, we use this formula. Okay, this formula we can use, and here you see this, for that value of mean 7, we take 0. It means whatever the mean, so that is 0 in case of a standardized value of x. Okay, so that's why here, okay, wait. Where I was, so now here it is 7. So 7 equivalent here 0. So in this case, in the normal distribution, the standard deviation it is given 2. But in case of a standardized, or you can say normal random variable z, okay, normal standardized normal variable z. Okay, sorry, here in case of standardized normal random variable z, we start from 0. Means if for random variable, if the mean it is some value, so from that we take 0 for a standardized normal variable. So now you can see in case of Z scale, so 0 is equivalent to 7, and here in the first case the standard deviation is plus 2. Okay, standard deviation is 2, so that's why 7 plus 2 you got 9, then plus 2 again because standard deviation is 2, then 11, then plus 2, then you get 13, that is standard deviation. But in case of Z scale, always the standard deviation is 1. Okay, standard deviation is 1. So from 0 it starts. If you go towards right, so it is plus 1, plus 2, plus 3. It means that will be increment by 1 only. So that's why here given in case of Z scale, the mean is 0 and the standard deviation is 1. And if you go to the left, so mean is -1 and standard deviation, mean is 0 in case of Z, and standard deviation is 1. So that's why if you go left, so it will be -1, -2 and -3. Okay, it means you can say -1 in case of Z, -1 in Z, that is equivalent to 5, -2 value of Z, that is equivalent to 3 for this distribution. Okay, so that's why for this x equals 9, Z written, so Z, that formula, it was x minus mu. Mu means mean, x minus mean divided by standard deviation. So x value here it is taken 9 and the mean it was 7, and then divided by standard deviation it was 2, so that we got plus 1. So for Z equals 1, the probability is 0.8413. Okay, when we use the table for cumulative probability, okay, table for cumulative probability, then for Z equals 1, the probability is 0.8413. okay, it means 84.13% chance here, 84.13% chance that the download time is that it was the question from a question, this example I have taken. I will explain some examples later on also, but in this here you can see, so from Z value we got the probability. Okay, from Z equals 1 we got the probability that this much means 84.13% chance is that the variable, or I can say the probability of getting the value x. Okay, okay, then thank you all. So we will meet again in the next session again. Thank you.